Hello everyone, I'm Paula, a final year physics major, and I'm presenting on K114 staining as a prospective gold standard in the diagnosis of renal amyloidosis. Renal amyloidosis is a disease of the kidneys, which filter waste out of our bodies. Proteins can generally pass through these filters without issue, but in renal amyloidosis, proteins become misfolded and create amyloid plaques, which prevent waste from exiting the body. There are currently 40 known proteins that can cause 40 different kinds of amyloidosis, with the most common forms in the kidney being AL and AA. The main problem in the renal amyloidosis diagnostic process is that it is slow. It can take patients nearly a year to obtain a diagnosis after their symptoms begin, which is a big problem considering the progressive nature of the disease. A patient diagnosed slowly will be in late stages of their disease at the start of treatment, leading to a greater risk of being put on dialysis and therefore a higher risk of death. Renal amyloidosis is diagnosed through a kidney biopsy. Amyloid proteins and other normal structures are really hard to see here, so a stain that preferentially paints the proteins of interest is used. The paint traditionally used to visualize amyloid is called Congo red. It does make the proteins easier to see, but different types of amyloid appear exactly the same. The tissue needs to undergo additional tests to find out the specific type of disease a patient has, which can take a lot of time. Congo red is also prone to false positive staining, where it gives an amyloid signal in healthy tissue. Finally, analysis of Congo red staining is traditionally qualitative, meaning that the results could be interpreted inconsistently among pathologists. On the other hand, a novel paint, K114, not only makes the amyloid easier to see, but it also color codes the different types. In addition, the signals that these proteins give off can be analyzed quantitatively, leading to a more objective analysis. K114 is also thought to be minimally prone to false positive results. And finally, if you image K114 stained amyloid repeatedly, it becomes brighter, making even extremely small amyloid deposits easier to see. Given these advantages, the main objective of this study was to develop an accurate process to test for renal amyloidosis using K114 that is faster than current methods. To do this, I was given 15 renal biopsies, 5 with AL amyloidosis, 5 with AA amyloidosis, and 5 healthy samples to use as controls. I then stained the specimens with K114 and imaged the samples on a microscope. Signals from the tissue were obtained and analyzed, and this whole process was then repeated with Congo red. As expected, Congo red was prone to false positive staining in normal samples, whereas K114 was not. Amyloid also appeared the same regardless of type when imaged with Congo red, whereas K114 stained AL amyloid blue-green and AA amyloid bright-green. These qualitative observations were confirmed by viewing the spectra emitted by each tissue type. Spectra from normal tissue, AL amyloid, and AA amyloid all look very similar when stained with Congo red, but there are some noticeable differences in the spectra when the 3 tissue types are stained with K114. To exaggerate these spectral differences, the K114 data were spread out over 2 dimensions. By looking at different portions of these graphs, we can determine quantitative characteristics that define each tissue type based on where these pixels fall. We found that if you look at this region here, a statistical analysis can differentiate normal from diseased tissue, and if you expand the region, another analysis can differentiate AL from AA amyloid. I also mentioned that K114 stained amyloid increases in brightness after being imaged multiple times. As expected, nothing exciting is happening in this normal sample, but in the diseased samples, you can see the amyloid glowing much brighter in the 50th image compared to the first image. We also believe that AL and AA amyloid would change over time differently. So again, we can spread out these data to see the differences better. But because our data are now changing in time, we need to add a third dimension to our analysis. As before, we can pick specific regions of these graphs to analyze to quantitatively differentiate between tissue types. It was found that AL and AA amyloid differ significantly in these quantitative parameters. In conclusion, K114 detects amyloid as Congo red does, but it is less prone to false positives. Spectral data can be used to quantitatively differentiate between normal tissue, AL amyloid, and AA amyloid stained with K114. Because this can all be done with one stain, this is already faster than the multi-step Congo red process. The use of both static and dynamic analyses can lead to increased confidence in a diagnosis, meaning that this interdisciplinary approach could replace Congo red staining as the gold standard in amyloid diagnostics. Thank you to the Maruve and Stiles labs, and thank you all so much for watching.